Yeah, hello everybody, and thank you for attending my talk. First and foremost, before I start, who is excited about a talk that is not about AI? Awesome. So I'm just joking, like I love AI, but I was talking with a colleague of mine, I was joking around, like, man, wouldn't it be nice to just see a presentation, like 1 hour, a guy trying to install Arch Linux or something for a change? This talk is about the struggles that we had to migrate an application to EKS. So if you were to ask me, hey, Andrei, what can I migrate to EKS? I would tell you, man, I don't care. I'll migrate everything. I don't care if it's Oracle Forms, .NET, or whatever, I'll do it. This is one of the migrations that kind of put my patience to the test. It was an application which was running on a single server, and it really wanted to be there. So it's a story about how it's not only from the ops side, it's also from the dev side to make things work. We did all that we could, but at the end it was a successful migration, but it wasn't without its problems along the way. So what will be the agenda for today? So we're going to talk about what we had in the beginning, what we found out when we started the engagement, how the target architecture looked like on AWS, how we approached containerization and migration, what were some of the fires that we had to stop post-migration. After we stopped the fire, how we stabilized and optimized the infrastructure, how we did for Black Friday, because that's the biggest test for anybody who sells online. Black Friday is the event. If that fails, then the whole year is a failure, basically. And then what were the lessons learned for us so that we could take away in future engagements. So first and foremost, what was the starting point? So basically, this travel agency, they had 2 places where they hold their applications. They had the main website, which was on a single server somewhere in Romania. And when I say a single server, I really mean a single server. It was a single server which they used PHP on, Apache, MySQL, Redis, MongoDB, all of it in one box. And at the other side, something which I found nice, is that their more critical system, they would run it on DigitalOcean. So basically, they also had it before, but they did some effort to migrate it to DigitalOcean. It still had lots of single points of failure, but at least some parts of that were scalable. If they needed, they could put a bit more droplets, but it would still be like PHP and some droplets, and that's it. How they would talk to each other is, and some of you might cringe at this, but they had some cron jobs that were directly querying the MySQL read replicas from the ERP. So basically, they were connected via the internet through firewalling, of course. Like the ports were not opened, but to build like the database of hotels and so on, they would have to query the ERP read replicas in DigitalOcean to get that data. And also, they had an API because the main websites, let's say, target audience is B2C customers, but the ERP was B2B. So basically, the customer for the ERP was the main website, but also other travel agencies. They did have some Redis, but it was barely implemented, so they were just starting out. They chose MongoDB. Basically, they wanted to have some sort of analytics for what people were searching on the website. Because if you want to take business decisions, then you have to see what people are doing. And they chose MongoDB to save all of the search data so that the marketing team can have a look and then, I don't know, see what they should boost on social media, whatnot, and so on. Also, as you are on a single server, the static assets, which were the photos, they were served from local storage. This is something, and I'll talk about it, that we managed to work together to change before the actual migration. It was pretty important. And not a lot of monitoring tools. I mean, they had what the data center gave them for like CPU, RAM, network, and so on for the single physical machine, which is helpful, but it doesn't help you when you're trying to drill down what is at fault. Like, is it PHP? Is it MySQL? Is it so on? They didn't have that. So this is what we had to work with, basically, to migrate to EKS. What? OK, I don't know why this stopped, but Anyway, why migrate? Why did they make this decision? Well, basically because it was a single point of failure. So if something were to happen to that physical server, everything would fail. Nobody wants that. So that was one of the reasons why they wanted to discuss with us to help them with this. Traffic spikes would cause downtime every time because they were limited by the amount of compute that they have. Basically, if you have a box, you're constrained by that box. So they wanted to be able to scale horizontally in case they needed that capacity. They didn't really work a lot on the caching strategy at that time. So basically, whenever they had a traffic spike, it would go directly to MySQL, which, as everybody knows, it can get overloaded pretty quickly if lots of queries are done in succession at the same time. And practically the biggest reason for migration was that the Black Friday in 2024 didn't work. So because it didn't work, they made a decision, OK, let's talk to AWS and let's try to migrate everything and make it scalable. So they engaged us in early 2025 because they wanted the Black Friday for 2025 to be a success. And they did that through AWS. We are AWS Advanced Partners, so this gives us the opportunity to help customers offload the cost of migrations through AWS and then also offer them credits. So when talking about the target architecture, from what you've heard right now, maybe some of you are thinking like, hey, Andrei, like, did you do a lift and shift first? Or did you use ASGs first? We don't do that around here. We went straight to EKS. Why? Well, because we didn't really have the time. We didn't have the time and didn't have the resources to just migrate step by step. So everything that was thought about was thought with having EKS in mind, because you have to think about it. We had to have the migration done, and Black Friday had to be successful. So you needed to have as much time as possible before going into Black Friday with a whole new infrastructure to make sure that things are working. So what did we use as a target architecture? Well, not something very complicated. And what I want to say here, not all of our customers are like high-tech startups, event-driven architectures. Like we try to help everybody. So, but these are the projects that I like. And these are some of the most challenging ones. So we started out with EKS. We used RDS for their MySQL database, DocumentDB for their MongoDB workloads, Elasticache for Redis. As you can see, we strive to use managed services as much as possible, because if after some time they wanted to, let's say, take ownership of the infrastructure, we want it to be as easy as possible for them and not need to have a lot of overhead of managing things. Cloudflare, they already had that, which was a really good thing. And it's something that whenever I do a migration, I try to find a solution to proxy the traffic somewhat. I don't care if it's Cloudflare, if it's CloudFront, or anything else. I don't want to depend on DNS when it comes to migrations. I've been in situations in the past where I didn't have any kind of control over what to do about this, and DNS, it can propagate in 2 minutes, it can propagate in 12 hours. You don't really have control. I had a situation where for 1 hour, I was debating if I was testing the old infra or the new infra, like looking at logs and trying to, OK, this request from you is that, and so on. It's a mess. If you're doing a migration, try to proxy the traffic somehow before so that the cutover is done fast. We use DFS for shared pod storage. S3 for the static assets, and as I said, this is something that together with them, we managed to do before the migration. It was pretty important to do it. We use Secrets Manager because we wanted to, their application doesn't use environment variables, it uses a configuration file. And we wanted to make it easy for them to change it, so we put it in Secrets Manager along with external secrets operator, so that they can go in AWS and modify the secrets file, and then it would automatically propagate to the pods. And of course, VPC with private and public endpoints. This is a must for any kind of project. This just doesn't work as it should. OK. So what we did about the containerization? Well, first and foremost, Apache was a no-go. Like, we didn't want that anymore. We just wanted to use Nginx, so we had to rebuild the configuration files and retest everything to make sure that it works as it worked before. And this did have its fair share of problems because they had a lot of custom Apache configuration that we had to rewrite. We had to go from manual deployments, like somebody SSHing into a server, to actually having pipelines, which that is, again, challenging in itself, because you have to build the pipelines, but the developers need to use them. So you're trying to also make them use them and make them easy to use. So we went, because they had the code in Bitbucket, we just went for Bitbucket pipelines for the CI part. And then to make it a bit easier for them, for the CD part, we use Argo CD. So they had a UI, they didn't have to log into Kubernetes to check the status of things and so on. The secrets, I've already talked about that. The static migration, we did it before. And for the database, here we chose the dump and restore approach because I'm going to switch to this slide. Usually, if you have two options, you either go for replication or dump and restore. And it depends from project to project. I don't think there's a better one of those, like one better than the other. If the application does not require like zero downtime migrations, you can do a dump and restore, because also the customer likes it, because they can test a bit before, not only selecting from the database, but also inserting. If not, we go for replication. In their case, they could handle a bit of downtime, and also they wanted this flexibility to test. And they also would handle a bit of stale data, because they could recreate it from the ERP. So we moved that to RDS. For DocumentDB, we just started with an empty one, because we didn't really need any data there. Developers had a staging environment before, so they could test end-to-end. We had Cloudflare to make the cutover fast, and the migration was pretty clean in that regard. So here I have a pretty high-level diagram. I won't stay too much on this, because it's things that I've already talked about. So what went wrong after the migration? Well, I mean, the first day was OK, but we started having issues pretty shortly after that. One of the biggest problems with the application, and something that they didn't test, they have campaigns sometimes. And for them, what it means to have a campaign is to have a landing page that they would cache in Cloudflare completely. They would cache the whole HTML page, so it doesn't reach the servers. Now, the problem is that their application, whenever it started a new pod, it had some commands that were creating the static file, the CSS and JS files, but each pod was creating them with a random name, a random hash string, and that's not an issue. If you're not caching the HTML page, it's not an issue. But if you are caching the HTML page, basically you're caching the first HTML page for one of the pods. So some requests work, some of them look like crap because it goes to paths which don't exist on other pods, and you get lots of 404s. So it doesn't work. This is something that they didn't test before, because when we did the migration, it happened that they had no campaigns active. So first and foremost, what we did was we disabled the cache. We went without the cache, but we tried to fix it somehow so that they could still cache it in Cloudflare, because we knew what were the issues with the app, and we were trying to use cache as much as possible. So we tried to move everything to build time, try to build the assets in the CI. The problem with that is that for the assets to be built, the pipeline had to have access to the database. So in order to do that, we had to create an on-premise runner for Bitbucket pipelines and then run everything there and try to give access. We did that. Somehow on staging it worked. On production, it still had some issues, because even if the files were already there, the application would still try to recreate them somehow. So what we did in the end is they came up with a solution from their side, and instead of caching everything in Cloudflare, they cached it in Redis, so they had a bit more leeway in what they could actually cache. So that is a problem that they had to fix. We also had a problem Some of the static assets were created not by the commands, but after the first request came to a pod. So basically, every time there was a deployment and or every time some pod restarted, the first request would always be a 502, and then it would work. So we had to implement some startup probes that would ping the contact page, and after it pinged, because it was the lightest page of the website, it would start generating whatever was necessary, and everything worked. The second problem, and one of the biggest problems, was when we started the project, they received credit, so nobody complained or nobody cared a lot about the cost because we were just building out the infra. But at some point, I did request, like, if you don't know, in AWS, in order for users which are not the root account owners to see the cost, they have to do something from their side. They have to click some checkboxes so that the regular IAM users can see the costs. So I send a message after message, please enable, I need to see the cost, I need to see the cost, I need to see the costs. They didn't do that. What I did after like 6 weeks, when we already were like half a month in like the cutover, I was in a call with the CTO, and I told him like, hey, we're in this call, let's also solve that problem if we are here. So he went to the console, and when he saw the costs, we both had, we looked at each other, and with a look of horror, because the costs were huge. The 7K was just for DocumentDB, it was not the whole bill. So what actually happened is DocumentDB, like Aurora, makes you pay for IOPS. So if your database is writing a lot, which in their case, it does write a lot because all of the searches they write to MongoDB is more used for write, not read, that generated the most amount of costs in there. So what we could do there, we just used an EC2 to hold the MongoDB because it was not that critical, but that was a bad surprise for everybody. So that's how we fixed that. Then, in the beginning of the collaboration, we didn't have access to Cloudflare, so we kind of relied on them to create the records for us. So we told them, hey, for S3, just create a record in Cloudflare and point it to this. They did that, and at some point, people are writing on Slack like, hey, the assets are loading really, really, really slow. And to our surprise, we found out that they did create a record, but it wasn't proxying to Cloudflare. So also part of the big costs were the networking costs, because every request was going directly to S3. And not only you pay for the networking to S3, but S3 can throttle you. Like, it's not a CloudFront. If you send too many requests to S3, at some point they start to throttle you, and it works very bad. So that was just like a simple click the button in Cloudflare to fix it. Also with Argo CD, as I've told you, it was not only the problem of implementing and creating a pipeline, but also the problem of developers who were not comfortable with this kind of setup, and also they didn't talk with each other because there were lots of changes done on the app side. For example, at some point they did a rollback, and then nothing was working anymore. And nothing was working because they also had to clear the Redis cache. But the guy who implemented it somehow, I don't know, didn't tell other people, or I don't know, but we managed to fix it, but it was a lot of downtime because they weren't familiar with the process that they have to do with all of the new features. So it's something that does happen when you're trying to do things as fast as possible. Problems appear, but you fix them along the way. And one of the key insights here, communication gaps will exist. And it's something that you should be aware of. Not all of the customers that you'll be working with are like, have a startup mentality or are like born in the cloud and so on, and that's okay. Like, not everybody needs to be like that. But it's important to have this in mind, and it's also for me something for the future to talk a little bit more and make sure that the communication is even better. So we fixed those fires. from the migration, the platform started being better. Then we had to make it even better and optimize it. So the issue is that we were in a situation where, okay, now it works. We didn't have any really big downtimes, but we have to work on the costs. We have to make it cheaper. You have to make it cheaper, but you have to make it work. So again, it was an effort on both sides because the application was really fragile. If anybody was doing any kind of, that didn't even have to be a DDoS attack. If you just search for a lot of pages on the website, you would generate a lot of queries and then the app just like would blow up. And it's something that you could put the most EKS in the world and it won't fix bad app design. So what they did was they shifted a lot from MySQL to Redis. And when I mean a lot, they had more than 16 gigabytes of cache data in Redis because they had to cache for every filter, every combination of filters, and so on, which sounds like a lot, but it worked. I mean, if it works, it works. It didn't fail anymore. We also, they rewrote one of the heaviest part of the application, which was the search. They rewrote it in Nuxt, and they put the front end on Cloudflare pages, and then the API is running on EKS. And Nuxt was a way newer framework based on PHP. It also had HTTP caching. It was like 100 times faster than what they had before. So we had some massive performance improvements, but we still had spammers. So when you have any kind of, doesn't matter if it's travel agency, if it's an online store, or if it's anything, you will have requests from Googlebot, Metabot, OpenAI, Claude, other spammers, in their case, other travel agencies who are scraping the prices to give better prices to customers. So we had to have a way in which we could leave the good guys to, you want to leave OpenAI and Claude, because this is the new way of searching for stuff nowadays. But we had to stop spammers. We did try to implement rate limits. We did try to implement CAPTCHAs from Cloudflare. That didn't work well. I think the only CAPTCHA that worked for them was from Google. But what we did, which had a very, very big impact for them, is we started monitoring the traffic. We actually have some monitoring in place which alerts us on Slack. And we blocked known bad ASNs. That was the best thing that we found to block on Cloudflare side without blocking too much or without blocking whole countries. Even if their target audience is Romanian, you can't block a whole country because maybe a Romanian guy or girl or whatever is in that country and they're trying to use the app again, it won't work. So we had to block ASNs, which, for example, data centers, big data centers, we knew that it didn't make any sense to contact us because they were not real users. We also blocked some Romanian data centers, which didn't make sense to do requests to the app. And this led to a massive reduction in junk traffic. And it's one of the biggest things that helped us with costs in this case. So for every company, there is a way to do it. Here, we had to go and surgically block the ASNs. Then it came to instance sizing and storage challenges. So because we had to somehow balance costs with performance, we had to choose the best type of instances on AWS. And you would think that the best types of instances to use would be T-type, maybe. But that's not the case, because one, they have very bad performance. And two, if you go over 30% CPU usage, you would start paying for extra credits, CPU credits, which at some point, you might as well just use an M-type. They will reach the same cost. So it doesn't make sense to use T-type. And for them, it didn't make sense. Also, even if the M5s were cheaper than the M7s, for example, the performance benefit that M7 have, and it is something that I can recommend that you do. If you know Vantage.sh, is that website where you can do like pricing calculators for AWS instances. They also tell you, like, they have benchmarks for different instances. And you can see how much more capable the 7th generation of instances are compared to the 5th and the 6th generation. So we tried them 7s. They worked, but they had more RAM than we needed. So at the end, we managed to go with C7 instances. We managed to use Spot instances for all of their staging environments, because even if they would have issues, let's say at some point they had some long-running crons that could run for like hours, it would have been better for them just to cut it off, but pay less than actually just leave it running. The DocumentDB/MongoDB disk was filling constantly, and it was also because there was legitimate search traffic. They would save a lot of stuff per each search that somebody would do, and there were also people who would spam the searches, like bots and so on. So we had many situations. Even if they did clean up the MongoDB every 24 hours, they had a cron. I would have situations where at 9 p.m. or 10 p.m. I was trying to reach somebody from their side, like, hey, dude, this thing is filling up. Like, it has 200 gigabytes, but now it's like 300. And I would constantly have to increase the disk size. But you didn't want to increase it too much because, again, you have to lower the costs. So there, again, we had to have some ways to rate limits, so that they also had to write less data into MongoDB because you don't want to write everything there. So we can keep it a little bit small. Downscaling as well. There were moments when we were like declaring victory. Hey, last 2 weeks was great. Let's downscale the MySQL database. And you would downscale it, and the next day it would have issues, and you'd have to upscale it again. So lots of these things could happen, and again, you could have unpredictable traffic that somebody could spam the website and just ruin your whole plan. So yeah, this was like how the architecture ended up in the end. We did also implement, so for them we had the Prometheus, Grafana, and Loki observability stack. We also had New Relic, so we could look together with them at traces to identify opportunities in the app. And this was also a very frustrating point because I would see like traces which were running for a minute, and I was like, okay, there's a trace here. It says like it has a lock that stays like 1 minute. Oh no, that's how the app works. So there are lots of discussions like this. But again, in the end, it was good. Also, we had PMM and performance insights for the database nerds out there, for MySQL from Percona. And how did we do for Black Friday? Good. It went well. No problems. Yes, I'm gonna rush. So no problems for Black Friday. Even if they had to deploy the search 2 days prior, the whole new search engine, we did that. We took the risk. The risk paid off. We had aggressive caching in place. They also fixed the problem with the main HTML page, the landing page that was cached. That was cached. Everything was cached. Everything were fine. They had record sales for Black Friday. So some lessons learned. Some lessons which not only for me, but for you maybe. Get billing access from day one. From now on, I don't care. I won't start the project if I don't have billing access from day one. Try to spend more time to understand the read and write patterns when it comes to databases. If you're planning to use some managed services from AWS, where you have to pay for IOPS, test production, test like production or pay in production. Kubernetes self-healing, it can help you. Migration is a people problem as much as a tech problem. And cost optimization never stops. You will never just say that, okay, I've reached minimum costs. You'll forever find something better to do. So with that being said, thank you. And also, thank you to our partners who made this migration possible.
Cool, thank you very much. That was a very nice presentation. So I have one small question what was the biggest challenge from your perspective? Like
The biggest challenge to solve or the biggest impact? Like the one
the
with
one to solve. The one to solve. The one
I think it was the one with the static assets that was driving us nuts, because we had to find ways. Like, we had ideas to put the static assets on an S3 bucket, do blue-green deployments for it to work. We tried lots of stuff. In the end, they just fixed them themselves. So not everything needs to be fixed from the infra side.
Nice, nice, cool. Are there any other questions? Any curiosities? Oh, okay.
Sure.
Would you go first?
Thank you. I have two questions. First one, what was your strategy for traffic migration from legacy solution to new cloud solution? And the second one, if you had any optimization for AI search, so it will index, has better indexing in when people do AI search.
Can you talk a bit louder? Sorry, I didn't understand the
So
questions.
my first question, what was your strategy for traffic migration from legacy solution to the new one?
For traffic migration,
Yeah.
well, we just put a maintenance page. It was not that complicated. Like, we put up a maintenance page. We had traffic proxy to Cloudflare, so whenever we changed the DNS records, it would propagate instantly, because it was actually a proxy change on their side. It was not a DNS propagation change. So we had the maintenance window. We did the migration. We had also a maintenance window on the destination. They had a way to test the application with the restore database. After they gave us the green light, after about 30 minutes, we just put the maintenance down. We send the traffic to AWS.
Thank you. The second question is if you had any strategy for optimization AI search. You know, the people also, so you can get a better indexing in AI search as well.
In AI search?
Yeah.
In AI tools?
Yeah.
I mean, not really. This is more a problem on their side. They did start to implement AI search tools for their website. First, they did, let's say they did a ChatGPT app that was like a prototype where if you had a ChatGPT subscription, you click that, and then it had a knowledge base that helped you search on their website. And then they actually did implement a way to search, like use regular language, and then it would recommend like itineraries for you, like to go to Portugal, or go to book this hotel, this many people, book this flight, and so on. I think somebody else raised their hand. I don't think that works.
I have 4 questions, but I'll only use 2 of them now, and for the rest.
Okay.
First question is, how did you coordinate deployments on the next pages and the application ones? Did you do any kind of coordination between what was deployed as a static website versus the API? Because that can become a problem, especially if you don't follow semantic versioning.
I mean, we didn't have problems in that regard. I understand the question, but they did build the front end and the APIs in such a way that it was backward compatible every time. So they didn't need to do anything special in that regard.
Okay, and the second question, for stress testing everything before going to production, what was the setup that you used, or were the customers the one that were doing the stress test?
I mean, we did use K6, but and you can stress test as much as you want. It's very hard to replicate real traffic. I mean, we could see that there were issues, and everybody knew that there were issues with the application, but there's nothing you could do. Like, even if you run a load test and it fails, it's not like you will stop the migration, or we had to go on, basically. So, okay, put more servers, it worked. If we put more servers, put more code there.
Throw hardware into the problem.
Exactly, throw thousands of dollars on the problem, and at some point it works. But yeah, we did do a load test, but I mean, you have the limitations from the app side, which you can only fix so much from infra.
Sounds like an awesome customer.
Yes. So these are my favorite types of customers, with the biggest challenges. You learn the most, not only from a tech perspective, but also from a human perspective, because you have to push and push and push and tell them, okay, it's also an app problem, and you have to give data to them and convince them that they also have to work together to fix this. So yeah, these are the kinds of projects where you really have to give your best on both technical and people side.
Cool. There are any more questions?
I have a short one. Do you think the customer was happy with the result? In the end, was it worth it for them to pay the price for the migration?
In the end, now, yes. In the like the previous months, not so much, because of the cost and so on. But what it matters is, in the end, we managed to solve everything on both sides. But they were happy with Black Friday, so that they had 0 issues. So yeah.
Oh, another question there.
Hi. Just one question. Before going live, did you consider doing like a gradual rollout so that some customers stay on the old platform while some percentage of customers go to the new one?
That's not possible because of the database. I mean, the only way in which we could have made that possible would have to have some sort of tunnel between the server and AWS, and the latency between Frankfurt and Bucharest is not very high, but it's too high to have like an API connected to the database. So that wasn't possible. We couldn't do that.
Cool. Other questions? If not, thank you very much, Andrei.
Thank you.